Hello everyone, and welcome to this presentation on Advanced Design America. My name is Etienne Lechasseur, and I work at GRAITEC Canada as an application specialist for Simulate product. The goal of this presentation is to give you an introduction to the software and show you some of its best features related to bridge design. Advanced Design America can also be used to design other types of structures, such as buildings, daycom towers, or industrial racking, but today the focus is really the bridge design features. Before jumping into the software, let me give you a quick introduction. ADA is an analysis and design tool based on finite elements. As the name suggests, it is made for North America and more specifically Canada. In terms of analysis, we can do linear and nonlinear static. It can run model and spectral for seismic design. It can also do time history, pushover, moving loads, and it can also work with construction stages, which is very important for bridge design. For the design features, it is all based on the Canadian CSA S6. I won't go through all of the features, but just some of the big points and some important ones. And so first of all, we have very good structures generators, so it not only generates the structures, but in some cases even the loads on them. So it can really make the modeling faster, so you can generate things like culverts, abutments, piles, and buildings. We also have a powerful moving load generator that can generate all of the moving load scenarios that you need for the S6, including all of the factors, as well as the positions of the vehicles when you have multiple lanes. For code check, it can do steel, concrete, and wood design. For concrete, it can also take into account pre-stress and post-tensioning. We also have a module for composite beams, either with steel or concrete, as well as a box girder module. It can do a foundation design and also easily generate the foundation like the one you see on the screenshot. And we have a bridge evaluation module for evaluating existing bridges. There's a lot more that the software can do, but those were just some of the points I wanted to mention before jumping into it to give you kind of an overview of the software. Now let's open ADA and have a look at the interface. So as you can see, I have two different bridge models open. The vertical toolbar on the left side and the bottom toolbar at the top. Those are the most commonly used modeling tools. Then above it, we have the different modes. So right now I'm in structure mode, which means I can edit the properties of the elements. So if I, for example, click on this beam section here, this is a composite beam. So when I'm in structure mode, I can edit all of its properties. Then if I want to apply loading or maybe consult some of the loads that may have been automatically generated by ADA, I can go to activate a load case. For example, I could select the asphalt load case. And so now I have access to the loading menu. Then we have the different result modes. So first, load combination. So it allows you to view the result either on screen or in table format of any load case that has been calculated. Then we have the envelope modes. We have envelopes for moving load results, as well as the envelopes for design, like ultimate limit state or the fatigue limit states. Then we have the modes of vibration for seismic. We have the design results. This one is for a steel element, but currently there is no steel in the structure. And then we have the rebar placement. So this one is for concrete design. Next to it, we have the icons to launch the different types of analysis. We have modal, spectral, pushover, time history, nonlinear time history, moving load. Then there's static analysis. So this one will also do the load combination calculation. We have analysis and design. And so when we use analysis and design, not only is it going to do design, but it's also going to launch every analysis that is necessary to do the design. At the top of the screen, we have a list of menus. So the first one is for file management. Then you have a series of editing tools, as well as the selection tools. So you can either define your own selection, create a selection, but you can also use some of the sections that are automatically created by ADA. So for example, if you wanted to select all of your columns on your model, ADA can do it automatically, or all your bracing, all your beams, so you don't have to predefine them for them to work. Then in view, we have the view options. In common, those are all of the libraries, so material, shape, reinforcement, cables, studs. There's a very extensive libraries that comes with ADA, so everything that would be commonly used in Canada should be part of the library. For example, we'll look at the steel material library. So except for the last few at the bottom of the list, those are all the default ones. And if you want to create a new one, it's easy. We just add a new line at the bottom of the table. Then we can enter all of the data. It's the same thing with shapes. So we have tables for each categories of shapes. Open, for example, the eye shape table. Once again, if we need to define a new section, we just go to the bottom, we add a new line, we can give it a name, then enter its dimensions, and all of the mechanical properties will be calculated automatically. So let me show you by copying the line on top. As you can see, all of the properties were filled in automatically. It's possible to override them. So all of the columns that are in yellow, you could force a different value. Those columns. If you need to create a shape that is not part of one of the default tables, you could go to custom build sections, or you could also use the section calculator. So the section calculator will automatically fill in the custom build table based on a DXF file. In the custom build table, there's no automatic calculation, so you have to input everything manually, but using the section generator, it's very easy to do. So let me show you an example. So we import a DXF file. And then we can mesh and calculate the properties. When it's calculated, it's very easy to import it directly in the ADA library. Material, section class for steel design. Then it's now in the library. So with the DXF, you have a lot of control. for what shape you want to create. We also have tables for ASHTO and the NEBT sections. Next, we have the tool menu. This has some of the more advanced modeling tools. Um, some of them are grayed out because they require you to select a certain type of element before you can use them. So for example, for members, you could split them in multiple sections, split them in precise position. Um, if we go to nodes, we could generate curved elements. For plate, we have a tool to automatically subdivide plates in different ways. So there's a lot of great tools here we can use for modeling. And we also have a list of generators. So starting with building generators, which I guess is not very applicable to bridges, but you could still use it. Then the culvert generator, this one is very powerful because it not only generates the geometry of the culvert, but also the loading on it. So the soil pressure as well as the vehicle, including the effect of the soil under the vehicle. So let me show you this one on a new model. If I go to Tool, Generator, and then Culvert, it's very easy to use. From the drop-down menu, we select which type we want to generate. For example, depressed arc with 3 radiuses. This is probably one of the more complex ones. Then I click on parameters to enter the dimensions. So even though it's just a 2D frame, it would actually be very difficult to model this one. Even just drawing it in AutoCAD, um, it's a lot more difficult than it looks. And modeling it in implement software it would be even worse. And so now just entering a couple of dimensions, it will be automatically generated for us. The default values. Okay. As you can see, the frame was generated automatically. Let me turn on the 3D view as well as the transparency so we can have a better idea of what is going on. We could also remove the gap that was added to better display the nodes. It looks a bit smoother. You can see the geometry is fairly complex. So there's a variable cross section. If we look at the foundation, and so there was elastic support with the rigidity automatically calculated based on the options we used. And there's also loading generated on the structure. So for the moving load, we would have to run the analysis. We cannot just display them on screen, but we can look at some of the soil pressure that was added. Backfill. Have also load case for loads applied to the side. So it would be possible to do it manually, but it would just be very difficult and time consuming. So this took less than a minute, but we're looking at maybe hours to do it manually. I don't want to spend too much time on the modeling tools, but the last one I want to show you is the tables that we use. So there's one keyboard shortcut that works for all of the tables, both when you're in structure, loading, results mode, and also for all the different types of elements. So it's a dynamic shortcut. So depending on what mode you're on, it will decide what tables will open. So if I'm in member mode, it will automatically open the member spreadsheet. It's a lot faster and you don't have to memorize a dozen different keyboard shortcuts for it. And what's really great about it is that you can, well, first of all, you can copy paste directly. So I could select this portion of a table, press Control C, then go to Excel, and press Control V. and I get the data directly. Then you might notice that here I get these ones and zeros and tree instead of getting this fancy label. We can also export it with the labels and with the titles at the top. So we could do copy with titles, and then we get the full text. We just have to be careful in Excel that sometimes it likes to convert things to dates and so on. So I'll text first. So now I get the full table. So it's the exact same table you get in ADA, except that you can now format it any way you want. And even with the label like this, you can copy paste both ways. So I could select this property here and paste it, let's say on this member. As you can see, it works just fine. There's a lot of other nice things you can do in this table. So let's say I wanted to change the cross-section for, let's say, this group of member. What I could do first is, let's say it was a longer list or one that's a bit difficult to select. I could right-click and section of identical continuous item. So this could be very useful when you have very long lists instead of having to scroll down. And then we could do replace, and what it does is it brings up the same dialog box that you would get if you were doing it from the normal dialog box. So it's very easy to navigate to get the cross section you're looking for. And there's a lot of other tools you can use from the right-click menu, sort, filter, and so on. One I really like is the modify tool, so that you don't have to bring your calculator or having to copy paste with Excel when you want to do changes on a batch of elements. So you can add, subtract, multiply, divide a group of values. So I could add, let's say 10, 15 degrees. And if you want to change the units, and so let's say that we're working on the node table, and maybe you don't like millimeters, maybe you prefer inches or meters. So any place that you have values in ADA, tables or dialog box, you can dynamically change the units without having to open a different menu or having to go back and forth. Now let's move on to loads and loads combinations. So one of the advantages of having a software that is really centered around one region or one code is that there's a lot of things that have been automated for you to minimize the amount of pre and post-processing that you need. So when you create your loads, you can assign them a type. So let me open the table of load cases. As you can see on my model, I already have a few of them. And so each of them have a different type. So for example, this one for girders, it's a prefab component. We have cast concrete, wiring surface, live loads. So we create different types of load that we need. So there's a lot more that we can create than what's listed here. So if I go to the S6 category, just to give you a preview, have. And while we're here, you can notice that loads that are currently on this model, they're applied at specific construction stages. So they're not all applied at the same time. So by assigning them the type, ADA will know in which load combinations they need to be included and with what factors. So then we can go to the load combination generator, and in just a couple of clicks, we can get the entire set of combinations based on the code we select. I have the S6 latest version. So I won't explain all of the options, but right now we selected that we want Seismic. We can also tell you what we want to do with the existing load combinations. We want to delete them or not. And I personally really like this middle option here, delete all load combinations except the ones edited by the user. So if you've created a couple of like manual load combination to test things out, you won't lose them when you relaunch the generator. And so then we could decide to filter and remove certain categories of load combinations. We also have shortcuts for the bridge evaluation and moving load menus. And then we get a preview of all of the different load combination. We could decide to unselect specific ones. So on this model, there's not too many types of loads, so the list of combinations is fairly short compared to most models. And so except for the first construction stage definition, the rest was all generated automatically based on code. We also have a easy to read description. We have the full definition, but it's cropped here, but we could still edit it. And we have a second tab where we can manually, easier to do it here when you want to create one or change the factors. Now let me show you the moving load generator. It's a very powerful tool in ADA, one of its main advantages in my opinion, because it is both extremely easy to use. In just a couple of clicks you can generate the entire set of moving loads with all of the correct factors according to code. But at the same time, if you have some more special moving loads that you have to define manually, you have a lot of control. You can generate almost anything. So I'll show you on the bridge we have on the right side here. So I'll regenerate the moving load on top of the bridge just to show you how it works. It will be easier to see, I think, if we remove the 3D view of this model. So in ADA, we use a reference axis to place the moving loads. We only need one for a bridge, even if there's multiple lanes, because we can apply offsets to the left or to the right to position our lanes. If we have different lanes that are not parallel to each other, we can use more than one axis on the same model. Then to generate the moving load, I can use the automatic generator. So we select what code we want to use, level of loads. We could generate 2D or 3D moving loads, so they both work differently, but ADA can do both automatically. We select what axis we want to use. In this case, it's the axis 1. Then what direction the vehicle will be moving. Normally we have them move in both direction, and so when we use this option, it's as if the truck was doing a U-turn at the end of the bridge and then coming back the other way. Then we enter the dimensions of the bridge, number of lanes that we want to have loaded simultaneously, and the scenarios with the correct offsets would be generated automatically for us. You can also see the list of vehicles on the right side used. When I press on finish, it will bring the load case spreadsheet where we have all of the different scenarios that were generated for us. Look at the first one, for example. So this was given automatically. We have a CL625. The results will be added to the envelope number 2. It's using the axis 1. We have the direction. Then we have factors for the S6. And if we look at the last tab, moving load case component, this is where we can specify what offsets will be used, and we can also put the factors, because typically when there's multiple lanes loaded at the same time, you have to put a reduction factor. So we can apply it, and then it's done, basically. We can also display it on screen if we want to confirm that we place the moving loads on the right location. It looks like it's a bit off, but it's actually correct. So the slab goes a bit farther on this side. Maybe I could bring back the 3D view. So So the yellow arrows, they represent the front wheel of the vehicle. And so we can see the different lanes. There's going to be also cases with more than one vehicle at the same time. So it was very easy to generate, and the library already has all the vehicles needed. S6. If you want to define your own vehicle in your own scenario, it's just as easy as creating a new cross section. So you add a new line, assign the correct properties, and then on the next tab we can position the wheel in any configurations you need to. This one, for example, is a 3D vehicle, so that's why we have both X and Y coordinate, and the X coordinate alternates between minus 0.9 and plus 0.9 because the vehicle is 1.8 meters wide. So this is the longitudinal position of the wheel. For launching the analysis, let's talk quickly about seismic and construction stages. So if I go to project configuration, I can see the options for the seismic accelerations. So we can do it automatically based on code. So we select the code here, in this case, the S614. There's always some factors we need to select based on the code. For example, the site class that will affect the accelerations. And then we can select the city. So this list comes from the Annex C of the National Building Code. So you don't need to look it up yourself. You can just select the city and it will bring the values automatically. It will also apply the correct factor based on the site class, of course. I don't want to spend too much time on seismic because it's a very complicated subject. The only thing I wanted to show you here is how easy it is to get the right accelerations on your model without having to look it up in the code. And then if we move on to construction stage, so we can see them in the pre-stressing tab. But don't worry, you don't need to have pre-stressing or composite beams to use them. You can use them on any model. But in this specific one, it's using pre-stressing. And so having multiple construction stage, it allows to take into consideration the long-term effect of composite beams and pre-stressing. It also allows you to add elements on the model at different stages. You can also add loading at different stages, as I showed you before, and it's all taken into consideration in the results and the finite element analysis. Speaking of composite beam, I guess I could show you how they're defined in ADA. It's actually very easy. So if I click on this one here, so as you can see, it's one single linear element. So it's not two different elements. So this really makes the post-processing of the result a lot easier because you get directly your M, your V, and so on. On the first tab, we can assign what section we want for the bottom portion. And then in composite beam tab, we can define what slab we want to use. We can also place rebars slab. So if we have a steel section, like on the diagram, then we could define studs to have ADA tell us what is the maximum spacing we should use. We can easily change the width of the slab, so we don't need like to redefine a new cross section. We can just change the value directly here. Number of studs, that's for steel. Then we can select if we want or not to automatically add the weight of the slab. Typically for composite beam and bridges, we prefer to add it manually so that we can control exactly at which stage will the weight of the slab be added. And then we can consider or not the reinforcement, so for positive, negative moment. And you can also see all the properties are calculated automatically for it. So even if the end calculation for these types of section are extremely complicated, modeling them in ADA is actually super easy. You could also look at the other model I had open to show an example with the steel section. One of the elements. So what we have here is a fairly large WRF cross section. And then if we go to the composite beam tab, so as you can see, we have 200 millimeter slab, have the effective B, and we can select at which stage will we get the composite action. Now to show you the steel design result, I switched to a simpler model. It's just a steel frame with a live load on top, and also I included the self-weight of the element. Load combinations were generated automatically. And so to launch the analysis, I can just press on Analysis and Design, confirm that there's 3 members in verification. So verification means that ADA will tell me what's the resistance, but it's not going to change the cross-section of the element. It's also possible to use what we call design mode, where ADA will try to find what would be the best cross-section, the most economical one that passes code check. But for now, we're only in verification mode. And so we can view the results in table format. You can see what was the most critical load combination for moment actual, the design load rate clause that's controlling the design, section class, and then there's intermediate calculation values. So here we can see the moment resistance, just a little bit. So the moment resistance, if the length were to be 0, the moment resistance for the full length of the element. So in this case, there's a lateral torsional buckling on the beam, so that's why you get a smaller resistance. And so you get all of these detailed value that helps you figure out where exactly is the 100.12% coming from. We also have a tab for shear, and I did not activate the deflection for this model. We can also see it in a calculation note, so we could either review or print it as PDF. As you can see, we have all the details here in a single page. So with the solicitation on the left side, the loads that were directly applied to the element. In this case, there's only the load because it's one of the columns, but there's load transferred from the beam. We have the shape properties, material properties, the combined forces, the resistance, and then the combined forces. To define the option for steel design, most of them are on the element itself. So if I open this beam here and I go to the steel tab, we assign a specification. So this is where we tell ADA what code we want to use. We can also put restriction on what cross section we want ADA to select for us when we're in automatic optimization mode. So this is what we call the design mode. And so we can adjust the settings for the lateral torsional buckling. We can override the K factors. We can reduce the net area, and we can also include stiffeners sections. Now let's go back to the bridge model to show you the concrete design feature, the pre-stressing, as well as some of the finite element results. So if we start with the results, so if I go to activate an envelope, I can select the ultimate limit state envelope. This was generated automatically by the load combination generator. You can see the curve on the screen right now. I have the moment MX activated. So it's in the display option menu that we select which results we want to see on screen. So I could, for example, add the MY. I could stack many more diagrams, but it's not always a good idea because the text will kind of pile up. We can decide if we want the text or not on them also. Now, if we isolate just one beam, so it's easier to view the results, I will select this one here, this continuous system, and hide the rest of the structure. Now I can move on to side view and get a better view of the moment diagram. It's very easy to adjust the size of the diagram. So there's an automatic setting that will try to get a good compromise. But if it's not good enough, like for example, in this case, I think it's a bit too small, it's very easy to scale it up or down as needed and to either or show the text. Text, we can also scale it up and scale it down. We can have the result in a table format. So if we double click, there's a default table that will open that gives you the forces, deflection at regular intervals. This is for the entire system. So there's always a min and a max because it's an envelope. But there's more tables that we can pull up. So if we go to results, envelope, so because I'm in envelope modes, I need the envelope menu. So for example, if we only wanted the minimum and maximum on each segment, we could use the internal force min-max. So instead of having the values at regular interval, we get 2 values for every member, useful for design or for quick checks. So we can do internal stresses. So there's a lot of different tables we can bring up. If we want to do the detailing of this continuous system, we could go to the rebar placement and open it in the rebar placement interface. And so here we can see the elevation of the beam at the bottom with the different section cut. In the middle, it looks like it's broken, but it's just because the section cut are too close to each other, so they kind of stack up. We can move them if we need to, but I'll leave them like this. The red lines are pre-stress or post-tensioning cables. I have not checked which one it is yet. In gray, so it's the rebars that were included in the model. And so if we look at some of the diagram, those are, for example, the last two, so we can see the MR versus the MF of the section. So in red is the capacity, and the curve in green is the MF, the moment. You can see exactly what's going on throughout the entire length of the element. Same thing in yellow and orange, the one right above it for shear. And so we have a couple of graphs like this that are very useful to get a very quick understanding of what is going on. But of course, if you want to see exactly what the values are and how they were calculated, we have tables for it. And results, so general results, that will give us the main table with the resistance. We have positive bending, negative bending moment, shear force, axial, and also a tabs just to show the cable position. But what's nice about this is that you have all of the intermediate values also. So if you want to double check something, it's very easy to do and to compare with your end calc. So you don't just get like one final value, you have all of the intermediate values also. So this is for positive bending moment. But anyway, it's the same thing, but it's just the negative moment. We have calculation for shear force, values for axial and moment, and then the other one is just the cable position for pre-stressing. With pre-stressing active, there's more intermediate results we can bring up. And we also have a table for the cable loss. We can see the losses at every stage. So this is why there's a lot of zeros in the table, because those were the stages that were not activated on this specific model. So we have the losses for stage 3, all the stages, and we also have the sum at the end of all the losses. So you can see here for stage 9, so we have relaxation of tendon, stress, shrinkage, and sum of losses for this stage. To edit the rebars or the cables, we have tables here for this. One thing that's nice is that if we do changes, the results get updated live. For example, if I delete there's a very nice dialog box we have to show results at every stage for steel and concrete. So it's not the same dialog box depending on if the main beam is made of steel or concrete, but they are very similar. So I'll show you the one for concrete. We can access at the top here. So I get the different types of results like stresses in concrete or bending moments, and I can get them at every stage. Stage 8, stage 3. It's very easy to get them, and to export them, you can right click and either copy data or copy the image. Now the final thing I want to show you is bridge evaluation. It's actually fairly easy to do. The difficult part is modeling the bridge, but once you have the bridge model, activating evaluation mode is it's just a few clicks. So if you look at the properties of the element, we have an evaluation tab that's available where we can enter the reduction factor for each type of force, so of resistance. So for MR positive, MR negative, VR, so for strong axis, weak axis, and then we have axial. There's a dialog box also when we generate the load combination that we can adjust some settings that will affect the whole model. So I'll show you very quickly. So we have some factors from the S6 to select. And then once we've configured it, all we need to do is change the specification to bridge evaluation, and that's it. Now if I relaunch the analysis, we'll get the results for bridge evaluation. If I reopen the same continuous system, we'll see the additional results that will be present in the tables. Okay, so now if we look at the table, we have the factors that are now multiplying the resistance that were not there before. And we have uh, the factors that have been added to the table. The F column is the live load capacity factor. Right now it's expressed in percentage. We can also display it as a ratio if we prefer. So once you have all the data that you need to create your model, it's actually very easy to activate this mode. I will now conclude the presentation. Thank you for watching. I hope that you will be interested in trying Advanced Design America in the future. If you have any questions, you can ask them right now on the platform, or you can send us an email at one of the address listed on the screen. Thank you.